I want to thank you, Linda, so much for joining this group and for discussing the NSF and in particular the Division of Materials Research. And I'm really excited to have you on board to join this group. I'm sure we have had lots of questions. I definitely had many requests for someone from the NSF to join and just share about your program. Looks from your background, at least, like it's a lot of exciting stuff is going on. And yeah, thank you for joining. You'll speak for a little bit. I'm going to post your longer bio here in the chat. And the title is called NSF Division of Materials Research, where materials begin and society starts benefiting. So thank you very much for joining. I'll be in the chat in case anyone has any questions. And yeah, the stage is yours. I will make you co-host now.
Okay, thanks, Allison, and thank you for inviting me to talk and have a chat with all of you in regards to how we think about, or at least as the Division Director of Materials Research, how I think about trying to invest in materials research and what might be relevant to this group's interests. So I have a short presentation. I do have 20 slides. I'll go through some things quickly. I mean, it would be useful for me to know how many of you are familiar with NSF structure and things like that. So if, I'm still getting used to the Zoom things and I don't get interaction with people. So
I am a little bit. I've had some NSF contracts.
Okay.
Not much detail.
Okay, so I'll just give my talk, and I think there'll be plenty of time for discussion. So I'm going to be talking somewhat of a high level, but I certainly can dig deep into things if people have specific questions. So I'm going to share my screen with you. All right, well, thank you for coming along to hear what I have to say about materials and NSF, and hopefully we'll both learn something. I hope to learn something from you, and I hope you learn something from me. I have to start out because I can't do any part of my job without meeting the vision of the director. And we have a new director, the 15th director of NSF. We call him Dr. Ponch. He's very energetic and excited and has been pushing big things for the foundation to pursue. And I'm sure you all heard about the new ideas that are coming out in some of the latest congressional discussions with respect to NSF. He has a very grand vision of not only of supporting the great fundamental science that NSF has always supported, but to help facilitate translation of those ideas to even have a bigger impact on society. And he wants to do that at speed and scale, and we're still trying to understand and come up with how what we mean by that, so the community can be on board. But basically, it's a matter of forming the appropriate partnerships, not just across NSF, which I'll talk about a little bit, but with other agencies, with other entities like private foundations, and other partnerships that maybe we haven't thought about. Really emphasizing people and reaching out to increase diversity and inclusion, not just in race and ethnicity and women, but also in geographic distribution, types of institutions, and so on. So we can really tap into the great knowledge of all people. And then, of course, translation. What is that? And working with industry and other entities that are going to translate the great ideas to help society. So I think this is kind of new and actually it's not new for NSF. If you look at the history of NSF, they used to have directorates that focus on applied sciences, also focused on translation. If you look back at the history, so we're kind of coming back again in really supporting this vision. So one of the current administration's priorities are the industries of the future, if you haven't heard about this. And of course, quantum information science with the National Quantum Initiative, artificial intelligence, another initiative that's national, the need for advanced wireless, and of course, the potential of biotechnology and advanced manufacturing to really, accelerate the things that the world, not just our country, needs in order to navigate the future. And of course, I think we can all agree that materials are enablers of technology, and materials research science is going to underlie the advancement in the future of all of these industries of the future. And I think that's well said if you are familiar with the most recent PCAST report. This is the Presidential Committee on Science and Technology, where they talked about re-energizing and scaling up the Materials Genome Initiative, which I'll talk about a little bit more later. But basically here showing that the potential estimate of economic benefit of materials innovations is between 123 billion to 270 billion. And so, need and the investments in materials, both fundamental science and beyond, is well understood by our government. And you may also be familiar with what was called the Endless Frontier Act. It's now being called the U.S. Innovation and Competition Act. And this is the act that is really will hopefully support Dr. Ponch's vision of having this transition or more fast transition of fundamental discoveries and understanding into use-inspired research and great things for the country. So let me start with this. I think it's really important that we're all on the same page what material science really is. And I love this quote by Rustin Roy, and Rustin Roy passed away in 2010, but he was one of the pioneers of the MRS or the pioneer founders of the Materials Research Society. And I really like this when I was looking around trying to think about how I could talk about this, but material science is a syncretic, and I'm probably saying that wrong, discipline hybridizing metallurgy, ceramics, solid state physics, and chemistry. And I think we can have biology and computer science and manufacturing. I think it's rather than, breaking off and having a new discipline, say, you have chemistry and now you have biochemistry, it actually fuses. It's by fusion rather than fission. And so materials researchers are always feeding off the great new ideas and new progress in chemistry and in physics and in math and in computer science in order to really develop materials and increase their ability to be used and translate into society. So I just wanted to just share that with you, because if you look across the foundation, and this is the organization of the foundation, even though the Division of Materials Research is in the Mathematical and Physical Sciences Department, which is unlike in academia, you don't find materials science and engineering in the physical sciences, usually finding an engineering department, but this is just the history of NSF. Materials research is also supported in engineering, and we work very closely with them on a lot of initiatives, and I'll talk about a few, but also in regular projects that come in. And engineering and DMR within mathematical physical sciences also collaborates across the foundation with education, computer science, and biological sciences. So materials research opportunities are not just in DMR. And I think that's key. And I think it's part of the reason because of the definition of material science. Okay, so this is what mathematical and physical sciences looks like. That's where my division that I manage sits. You can imagine that we work very closely with chemistry. I note that many of your members in this molecular machines group are from chemistry or chemical engineering. So we do work closely with chemistry. We also work with math and the physics division. And so I think the key message I'm trying to make here is that in NSF, we don't work in isolation from each other. We work together and we try to prepare opportunities that advance science as a whole and not just for individual. And especially for me, it's a challenge because it crosses the whole foundation. So this is what DMR looks like right now. We're a pretty big division, one of the biggest divisions. Our budget's about $330 million right now. And I think we have the most diverse types of programs and the most diverse interdisciplinary type projects, not projects, but programs. I mean, types and interdisciplinary types of programs. So we support national facilities. You're probably familiar with the National High Magnetic Field Laboratory, the CHERNS, which is the Center for High Resolution Neutron Scattering at NIST. We support a sub-facility there. We now support a sub-facility at CHESS called all these acronyms. It's called CHECS. It's Center for High Energy X-ray Sciences. I encourage you to look at the national facilities webpage in our webpage, because there's lots of great instrumentation that's available for free for all of you. We also support the NNCI, National Nano the coordination network that engineering manages, but we also help to support. So we understand the importance of nanotechnology and nanoscience. We also, one of our newest programs that Charles and now Cosima Boswell are managing is called the Materials Innovation Platform, and I'll talk a little bit more about that one later. Everyone's probably most familiar with the MRSEC program, Materials Research, Science and Engineering. You may not know this is the first centers program at NSF. These were interdisciplinary research laboratories developed by DARPA back in the 1960s. They were transferred from DARPA, ARPA, or whatever it was at that time, to NSF in 1972, and DMR was created around the Centers program. And it was the first opportunity for people in the United States to apply for funding for interdisciplinary research. That started in DMR. And of course, that's one of the missions of the MRSEC, is to promote interdisciplinary research on the campuses that the centers are at. You may not be familiar with the PREM program, really relevant right now. We're one of the only divisions across the foundation that actually has a program for broadening participation and creating pathways for students and faculty and postdocs from underrepresented groups. It's called Partnerships for Research and Education and Materials. These grants actually go to minority serving institutions, and the goal is to they come in with a partner from one of our DMR funded entities, whether it's a center, a MRSEC, or one of our facilities like MagLab or one of our materials innovation platforms. But also DMR also manages right now 2 science and technology centers because materials are so prevalent. So any of those sort of entities they can match up with to do great research, but also to devise a pathway for increasing either retention, recruitment, or graduation of students from underrepresented groups, so we can increase the pipeline. And of course, when you're working at all those levels, you not only increase the pipeline in materials, you increase in chemistry and physics and a number of other areas, because many of the MSIs have science departments and they're not necessarily focused on materials. So it's a way of increasing also the interest in materials research. One of our newest programs is Designing Materials to Revolutionize and Engineer the Future program. This program I will talk about later. It started off as a Dear Colleague letter, became a solicitation with a full-time program director in 2014, and now it's grown that we have 2 other rotators that have come in to help with the program. To the right, then, we have our topical materials research programs, and we have 8 of them, and these haven't changed much over the years. I put them sort of in the order of size. So the number of proposals that we get for condensed matter materials theory, which covers all of materials, not just physics, but engineering materials, all kinds of areas of materials theory and computation. Now data-driven research is probably one of our largest programs. Condensed matter physics, it's also a very large program and serves a broad community. Solid state materials chemistry, probably one of the places that you'll see. I used to be the program director for solid state materials chemistry many years ago when I first came to NSF. So molecular machines and those types of things that underlie the types of research that this group is most interested in probably falls a lot under solid state materials chemistry. And also in the chemistry division in their program, macromolecular, supramolecular, and nanochemistry. Those 2 programs talk a lot and share a lot of PIs. And so it's important that when you are looking to get your individual research projects funded, that you realize that chemistry and the division in chemistry and our division do talk to each other, and we can help amplify investments in your program. So it's good to talk to program directors from both divisions. And let me just finish here. You can see the rest of them. I don't have to read it to you. We have EPM, and biomaterials is one of our newer program. We just hired somebody new that will be starting in August. And then, of course, you have the traditional metals, polymers, and ceramics programs, which this is the breadth of what we support. Unlike engineering, where some of the programs can be a little bit more prescriptive, and there'll be many more layers of different sections underneath the program. These programs are very open. You can go to their synopses. They're very broad, and it doesn't even have to necessarily be in that synopsis. If you believe it's part of that program, you can discuss that with the program director, because we're open to all great new ideas in these areas, and all these programs share all the projects that come in. So you're never isolated with one program director. So I hope that's helpful for you to see the breadth of this program, and I can answer questions about any of these programs if you have them. So let me move on and just tell you about an opportunity. I wanted to make sure that because of the COVID impact, the foundation did a study, joined a team to find out and talk to people in the community, but also across NSF, of who was most affected by COVID impact. And as you read in the literature, in the news, women, those from underrepresented groups, those from institutions like our two institutions that may have less endowments and so on and so forth are more affected by the effects of COVID and the pandemic over the last year. And so MPS, the Mathematical Physical Sciences, and DMR is participating, launch these two programs, LEAPS and Ascend. This is for pre-tenure faculty from from these different types of institutions. It's sort of like a pre-career sort of support for these researchers. And then the second one is for postdoc fellows from underrepresented groups. These are due in June. So if you know people or you are interested or have someone that might be able to apply to these opportunities, I'll share my slides with everybody, okay? Let me tell you about some cross-agency solicitations. I told you DMR collaborates across the foundation. Things that have already been ongoing that aren't available right now, but will be available again in the future include mid-skill infrastructure 1 and 2. And this is one of NSF's big ideas to fill the gap between, the MRI program, major research instrumentation, which goes up to about $4 million, to MRFEC, which builds things like ships and telescopes, which goes up to over $100 million. There was a big gap in the middle. That's what these two mid-skill programs fill, and it's for the whole foundation. And so mid-skill 1 goes up to, I believe, if I remember correctly, 70 million. No, wait, it goes up to, I can't remember. It goes up to 40 million. I don't remember off the top of my head, unfortunately. It's in that gap. You have the one, and then this is the bigger one. And I'm sorry, I have so many numbers in my head right now, I can't remember exactly. But if you're interested in that, we've had great response from the materials community. Last year, we funded a new a neutron spin echo spectrometer that's being built at University of Delaware that will be transferred to the NIST facility in Churns for the community, and that's studies for soft matter. And then just last year for mid-scale 2, Cornell Chess was successful in getting a 30 million plus award to build a high magnetic field beamline at Chess. So they'll be the first in the world. So that's pretty exciting. So if you're interested in that, so I also talked about, the advancement of data and the tools of AI and machine learning, which are really important. So we've been building the infrastructure to help communities take advantage of that over the years. So we have co-invested over the years with the Computer Science Directorate with respect to building the cyber infrastructure and now the data infrastructure to support that. And this is just one opportunity here. There's a lot of projects that are funded for materials researchers. That's just finishing up now. But we also had last year the future manufacturing solicitation, which is just winding down right now, but it will probably continue to be available to you. I can answer questions on that. But two that aren't out yet that you might not be aware of is the Artificial Intelligence Institutes is going to be coming out soon, and also this Semi-Synbio. And this is basically using synthetic biology for advancing semiconductor technology. And this is the third year it's come out, but it's the second year DMR has been a partner. And the people that you see associated with these are people that you can contact that are related to DMR if you have questions. So let me just talk real quickly with respect to the AI Research Institutes. The first solicitation supported, there were 6 of them that were funded. 1 of them was supported by chemistry. So for those of you that I think this group might benefit from that particular one because it's more molecular sciences and AI. And so these entities are meant to not just serve the institution that they're at, but to serve the community. So I encourage you, especially this group, to look and see what might be available and learn from that entity. DMR funded 2 planning grants, so I can talk about those, but we're looking to fund something bigger later. For those of you that are interested in maybe adding AI type activities to your current NSF funded work, MPS issued a Dear Colleague letter, and this is open right now. We can provide supplements, either supplements as shown here to existing funding around these ideas, money to support your student as an intern in a AI institute or industry or something to support these advances, or an eager or raise. And these are seed funding. Eagers are, they don't go out for review. They supply up to about 300K in support of 2 years of doing something high risk, high impact. The raise is bigger. It's 5 years and $1 million. It's teams. And it's meant to cross disciplines. So these opportunities are all available. So I encourage you, if you're interested in adding this to your research opportunities, or you know people that have NSF grants, please let them know of this opportunity. Okay. All right. So when Allison invited me, she said interested to kind of know, how we, what our priorities are, how we invest in things. Of course, we support a lot of studies. The main study that I initiated with Linda Horton when she was head of BES materials at DOE was this National Academy of Science study on materials research. In the last decade, there hadn't been something that covered the whole spectrum of materials research, including the materials engineering part of materials. And so we thought it was really important, and it came out in 2019. I think one of the most interesting conclusions that came from that, and there were many, was that MGI, which I am going to talk about, and I keep saying that, but NNI, the National Nanotechnology Initiative, had the biggest influence on material science in the last decade. So nano is pervasive. I mean, we don't have a separate nano program, but it's pervasive across all of our programs. So this is very important, and we continue to help foster investments in those areas. But you see, we've been investing in the infrastructure needed to advance the Materials Genome Initiative, the individual programs based on the polymer decadal study that Andy Lovinger works across the agencies, supports each year, a lot of emphasis on sustainability, and the future of polymer research. The solid state materials chemistry community responded to the results from the frontiers of this major study to look at hybrid systems that there was less investments in. So this study may inform some things that you might be interested in. And finally, electronic photonic materials also did a similar one. Right now, we've initiated a National Academy of Science study to look at our designing materials to revolutionize and engineer our future program. We want to understand how that program is helping the country realize the vision of MGI and what we can do differently with it in the future. And so you may be invited to participate. I don't know if you have views on that program. You should contact the National Academy and say you want to have your input, because they should be soliciting input from the community. So just to let you know that that's ongoing. Okay, let me talk about MGI real quick. And I don't know, I only have a few more slides, so don't worry, I'm almost done. I've been on the national, the subcommittee for Materials Genome Initiative since 2015. I'm one of the co-chairs with Julie Cristallo at ONR, Jim Warren at NIST, and Lisa Friedestor from OSTP, and she's also the lead for NNCO. We are just completed, I just sent the draft today, the final part of it, of the new Materials Genome Initiative Strategic Plan 2.0 will be coming out later this summer. And if you're not familiar with MGI, the idea behind it, which was launched in 2011, is we need to do a better job of integrating and iterating our information and knowledge between computation and experiment, and then use the digital data to help us do that better in sharing. And so it's really about bringing and increasing the ability for computation and experimental folks to share information and share knowledge so that they can advance both their fields faster. The second thing that's important is we need to be able to do that along this whole materials development continuum, but not in a linear fashion. We need to do it in a way that we can accelerate this process. So during the first 10 years of the MGI, so this is 10 years, it's 2021, each of the agencies participated and supported a lot of activities that promoted this. Sharing of data, computation, integrating of these tools, creating new computational tools. But each of these pieces were done at different parts of the materials development continuum. Going forward, what you'll see in the new MGI strategic plan is an effort to unify this materials innovation infrastructure in order to not only integrate and integrate at discovery, but to make sure that this knowledge moves up here and moves down here, and then understanding of things that aren't working at the design level move back here, and so on and so forth. It all makes sense. We all know this has to happen. We don't have a good structure in the United States to do it well. And so hopefully the MGI strategic plan will inspire you to help us to build a better materials innovation infrastructure to realize the ability to discover and deploy materials faster, at half the time and at half the cost, or whatever the original mantra was. Okay, so I'm a big advocate of this, as you can see. If you're interested in hearing more about it, there's a YouTube video between Julie, Jim, and then a representative from DOE talking about the MGI initiative and what the path forward is in the future. So that's available for you to look at. So I said I would talk about DMRAF. We just finished the competition. We're in the process of making recommendations for awards. I think the thing I want to mention here is DMRAF isn't just in DMR. It includes math, it includes chemistry, and then it also includes all of these divisions in engineering and all of these divisions in computer science. And this year it included the Air Force Research Laboratory and the Air Force Office of Scientific Research. We've had expressed interest from other federal agencies that may want to participate in the future. The number of proposals that came in was almost double what it was the last competition. This is a biennial program, and it's across 3 directorates and 9 divisions. And so we have a lot of people working on this. And basically, it's completely material agnostic. It could be anything from developing something that doesn't exist to taking something like a node metal alloy and making the processing of it more efficient. All of these things that occur across the materials development continuum. So if you have questions about this program, I would be happy to answer you. This program will continue, and the next time it will run will be 2023. The second program that we initiated, partly due for the Materials Genome Initiative, was basically a program. It's a DMRAF on steroids, I like to call it. So instead of it being a team, we're talking about a community. So using the same philosophy of iterating between basically computation and characterization or experiment and getting the data and sharing the data, but it's also about community building around a problem and building unique tools that aren't available in individual laboratory, but are available as a user facility across the nation. Also available in these platforms are samples, whether they're crystals or films or know-how. That's what this new Materials Innovation Platform program is about. We have 4 of them right now. Paradigm, 2D Crystal Consortium, BioPacific MIP, and GlycoMIP. The first 2 were funded in 2016, and they're really focused on 2D materials and what the interface with other materials for the future of electronics and quantum materials. So there's a lot of interest and capabilities at those, and I encourage you to go and look. And they just were renewed about 2 weeks ago for a second 5 years. So take a look and I can answer your questions. The 2 new ones that were funded in FY20 were challenged to converge biological sciences, biology, and materials research. And we came up with the BioPacific MIP and GlycoMIP. The BioPacific MIP uses synthetic biology to develop the starting materials for the future of advanced polymers. GlycoMIP is taking the complicated natural compounds of glycans that are these big, carbohydrate molecules that are very active in biology and not well understood, but could have really important properties that can be exploited for materials. And so this is this GlycoMIP Materials Innovation Platform is co-funded by the Biological Sciences Directorate in the molecular and cellular biology. So we hope to have both biologists and material scientists and chemists and physicists come to these platforms and share information, ask for samples, put in user proposals, but this is open to you and the user community. So I just have 3 more slides, and I want to tell you a little bit about something that I've been thinking about, and it's ways to engage the community in order to create more convergence of ideas. And one of the areas that we're interested in is in creating new ideas around biotechnology. And one of the things that resulted was what you saw for the synthetic biology applications for that Materials Innovation Platform. In 2018, we started convening the synthetic biology community with our biomaterials and soft condensed matter physics community. And this includes collaborators from chemistry communities also. We created what we called a square table, and it's not a round table, it's not an ideas lab, it's kind of a combination of that. And basically wanted people to think about not just discovery and development, but about deployment and decommissioning. So in this idea, we brought in the regulators, because in biotechnology, you got to worry about how the FDE and EPA are going to regulate whatever it is you create. And also a number of representatives from DARPA and other agencies that are interested in the future of biotechnology. And we held 3 square tables, as you can see there, one on living interfaces, programmable interfaces, and information-driven biomaterials. And at the end of this, we gave eager or C grants to some of the researchers that crossed between these communities to develop new ideas to address these issues. Now, why did we do this? One of the reasons I was really interested and noticed that there were no projects in materials division since I've been there that were exploiting the tools of synthetic biology. And so we met with the EBRC, the Engineering Biology Research Consortium, which is an outgrowth of a previous engineering research center from engineering on synthetic biology many years ago, and asked them, they were interested in creating a roadmap for materials. So we supported that. And many of the researchers that participated in the square table on the last slide contributed to this roadmap. This roadmap is now available to you. If you're interested in these tools and what the challenges are for the future and using them for materials and manufacturing and sustainability, I suggest you look at this. This is something I will be looking to in developing new opportunities of the future. And finally, I just had this Bio-Pacific MIP. I'll let you look at that. This is my second to last slide. We did initiate a number of new square tables, not just with DMR, but with our colleagues in chemistry and physics and astronomy. And we've been working with the National Cancer Institute to try to, if you think about it, cancer is a living material. It does lots of things. It senses, it spreads, it infects things. And maybe there's things we can learn from it. So we created a new square table where we took the cancer biology community, the synthetic and systems biology community, and our biomaterials soft condensed matter community, and did the same thing, where we looked at some of these questions as shown here. And that report hopefully will be coming out soon, but we're working with the National Cancer Institute to try to learn and get different perspectives on similar problems. And so you may see some new opportunities from those square tables in the future. So that's all I have. There's much more. These are pictures that I took during the pandemic when I needed to get out of the house, and I had a lot of fun playing with my new iPhone. I just wanted to share it with you. So thank you, and I'll stop sharing my screen, and I'm available for the full hour to answer your questions.
Wow, this was fantastic. Thank you so much. I mean, yeah, what an overview. Thank you very, very, very much for, yeah.
You're welcome, Allison.
It's really, really stunning, I think, how many opportunities are arising, also how much cross-disciplinary work apparently is happening, how much focus is on tools and even, you know, incorporating more of machine learning into all of these aspects. Really, really exciting stuff. I think I'm really hoping you share the slides with me so I can follow up.
Oh, absolutely. I'll
take notes.
I have no problem.
Okay, great. Awesome. Because I think there's lots of folks who would be really benefiting from this if I shared it in a follow-up email to the rest of the group. And so I would love to include quick slides and maybe do a few video shortcuts. Okay, enough from me. We'll move to the questions. And first one, we have Tom.
Hi, Linda.
Hi, Tom.
Great presentation. And exciting that we're coming up on the 10th year anniversary of MGI, which is June 24th.
Yeah. Awesome.
My question was, and NSF has been supporting these AI institutes, and you mentioned the one that Champaign-Urbana has been taking the lead on, the one that is in chemistry.
Yes.
But I'm interested in what your thoughts are about the opportunities when we combine automation, high throughput experimentation, and different forms of AI and machine learning, like active learning, so that the machine learning is not only analyzing the data, it's informing what experiment to do next. So really creating a closed loop system, number one. And number two, there are some fields that have made a lot of progress on inverse design. So as opposed to predicting the property of a material, you say, what property do you want? And therefore, what material would give that. So the field of nanophotonics, for example, has made a lot of progress on using inverse design. So do you have a sense for whether we're getting closer to that sort of long-term challenge, and whether there's investments that NSF and other funding agencies could be making, like labeled training data or things like that, that would accelerate our ability to do inverse design?
It's a great question, and my short answer is the federal agencies that are behind the Materials Genome Initiative are, behind supporting the types of things that you just talked about, and all of the things that you talked about are addressed in the new MGI strategic plan. We understand that there's a need. I think I sort of said it. You can do as much as you want in a team, but if that team's not connected to something, I mean, you can develop and design something, but if there's two aspects here. One is to use computation so you can shorten the design and design things faster. Another is if you actually design something and make it, moving it down the materials development continuum. And those are different problems, but they're interlinked. So you need to have the ability to use AI and machine learning and sharing of data along all of the sectors of the materials development continuum. That is our biggest challenge. Because if you really want to do all the things that you say you want to do, you have to have active sharing of data. We have to have a place to put it, and people have to know it's there. We have to have a way, and I'm speaking to the choir. You have to know that it's reliable data and all those kind of things. So the agencies are actively working on this, especially with respect to materials. And I think based on what you saw from the PCAST report, that there's very, very strong support for MGI and the vision behind MGI and all the things that you just mentioned underlie that. And so my longer answer, it's getting long now, is that there are going to be more opportunities to support connecting the types of things that you're talking about. And that's going to take more cooperation with engineering. And I think with the new TIP directorate that Dr. Ponch has talked about, and that's being proposed in the FY22 budget, that the connection and the automation and the connection between materials discovery, design, and manufacturing, where you have to start integrating all of the automated components of characterization and processing and synthesis, that it has to be done, and we have to find a way to do it. So I know I can't give you any more information than that, but yes, you will see more. You will see more, and I will continue, and I hope that you will continue to give us more information about what's missing still, especially when the strategic plan comes out. So I hope that wasn't, I just kind of rambled on a bit, but I hope that was helpful. So, okay.
Thank you. All right, next, I think we had Steve. If you can't unmute Steve, then maybe I'll take Gail first.
Well, I was just asking, we heard about the cable program a couple of weeks ago, and I was just wondering if the cable program was also, if this department was also involved in cable. It used to be called Covetics. It's the mixture of carbon and metals. That has
I don't know the
I think
cable
that's-
program. Is that in CMMI? Is that in engineering?
It's a DOE, Department of Energy program.
Yeah. No, I'm not familiar with that program off the top of my head. Sorry.
Okay, well, you know, if you really want to be multidisciplinary, you could get your materials people involved with that. But I
Okay.
don't know if it cross boundaries to DOE or not, but.
Well, actually we do. And, you know, there's so much going on at every agency. And actually I've heard of cables before, but I don't know in detail about it. But that's one of our challenges. And one of the call outs in the strategic plan is there needs to be better cooperation if we really want to advance things, because there's a lot of great things going on in the different agencies. And we do try to connect, but it's not easy. And so we're well aware. And I say I've been saying this lately, is it's not fair to the community that we don't connect better, because, you know, it's easier for you to, you know, try to figure out what everybody wants. And I'd rather have you spending your energies just doing your good thing. And you know what I'm saying? So, so we're well aware. And I think Dr. Ponch, one of the first things he did when he joined NSF was go and meet with all the other agency leaders. And his big thing is on partnerships. So I'm hoping that we can make some progress there. Thank you for your question, Steve.
Awesome. Thank you. Gail, you had one?
Yeah. And can you unmute Marty as well, just in case he wants to chime in here? Linda, very, very exciting and very challenging. And
Yeah.
so on the exciting and challenging thing, so let me just ask you a very practical question. And then, for example, as I'm looking at this map of all this stuff you're doing, and then I'm trying to map what we're doing onto it, I'm going, oh my God. I mean, where do you connect? What's the point of entry? So you're highly, you know, you're interdisciplinary. So our technology is, we've done some stuff with NSF, but really been over at DOE for, you know, and we were the splash page for their AMO site from 2016 to 2019. And it's like, and then looking at what you're doing, it's like, oh, wow. Okay. So we're highly interdisciplinary. We are applicable to a range of products. when I look at our variety and then I look at your variety, I go, I have no idea where to start. I mean, how do you?
Well, I mean, first of all, I mean, there are programs. I mean, the DMRAF program accommodates any type of materials research, and it's whether it's chemistry driven or physics driven or engineering driven. That's probably the best place for a team to start, because you can start at the very fundamental level and then actually through renewals carry it through to technology development if you want to. And we've had teams that have done that. So if I was going to recommend anything, I would look at that. I mean, has anybody submitted to the DMRAF program or been successful? Because if you haven't, I mean, it's, yeah. So Cheng Feng, yeah, did you get an award?
Yeah, thank you
Awesome.
for the
Yeah, you're welcome.
kind support. I got a career award from SSMC, so
Awesome.
I was supported by the DMR currently. And I actually have a question, Linda.
We'll come back to you, Gil, real quickly.
Okay, no problem.
Yeah, so so I'm a junior faculty, and I'm curious about, if we have multiple applications, especially join these multidisciplinary, interdisciplinary teams, are we expect to have a senior colleagues to lead the effort, or is how and there's also DMR has limited submissions per PI, so how does these play into the application in these interdisciplinary programs?
Good question. I don't think anybody would discriminate against 3 great assistant professors coming in and starting, a new DMRAF project. We have plenty of those and we encourage it. I think most of NSF, I mean, part of the review process is whether you have the expertise. I mean, the experience doesn't matter as much as the expertise, because we want to initiate new things. So I don't think you should ever be afraid to come in without a senior person on your proposal. Okay, so I would encourage that. At least in DMR. I won't speak for the rest of the divisions. And if any division, whatever. But the second thing is that, what was the second question? I know you had a second question. Sorry, I lost.
The second question is about limited submission per PI.
Oh, that's right.
Per period.
Yeah. So we have an open window policy for many of our topical materials research programs now. So it gives you the opportunity to submit a proposal basically anytime during the year with some guidance, because there's sometimes during the year, they're busier than others, but it's basically open. And the reason that we exclude that is because people will, continually submit proposals. And so you can submit 1 TMRP program a year, okay, 1. And if you, and then, but you can also submit a DMRAF or any other, you're not limited to anything else we offer. It's only amongst the TMRP programs, which are those 8 programs that I talked about. And like I said, the only reason is because unfortunately people come in and submit. I can't imagine one person that submits a proposal to every program that they have expertise to put a proposal in every program, but people do it. And it's a lot of work for all of you. And so we try to limit that. That's why. So I'm sorry about that, but put your best proposal in. Okay. So let me go back to Gail. I think, how do you navigate things? Well, first of all, if you have an idea, I'm always more than happy to talk to anybody about doing things. One of the things I'm interested in is, you saw my square table activities. If you have communities that you want to bring together, to really kind of push the needle, or you want to help us create sort of a new sort of, you see an emerging area that you'd like to push, we support those activities. So, new square table activities, if you want to call them workshops, I hate that word, but that might be one way. If you see DMR as a place, or materials or NSF as a place to take what you're doing. And, I'm always open to, where aren't you seeing opportunities for what you're doing? What is it that you need, support in? And I can better help point you to other things, but also just get you started in things. Okay.
Oh, that's great. That's absolutely great. Yes. Especially you've got points of synergy that emerge, which create completely new opportunities that aren't on the list yet. So the fact that you're there as a as an active participant in supporting, creating, and then structuring what could be done with new things is great, because very often what you see in some of these in the department programs is somebody has identified a current solution given available technology, and then that's being promoted. But then what that does is excludes all the other possibilities of superior solutions. Right. So
Thank you,
Well,
Gail.
feel free to reach out to me, Gail. It's no problem.
outstanding. Okay, will do.
All right, thanks a lot. Next one up, we have Ted with a request.
So you mentioned the semiconductor synthetic biology work. Could you give a couple of examples of that? Because I can't picture what that really is.
Oh God, you put me on the spot.
Sorry. Or just always point me at a PDF or something.
What I would do is the easiest thing to do is type in semi-symbio. It'll take you to the NSF webpage, and then there'll be a link at the bottom that links you to currently supported awards. It's basically, you know, connecting you using, if you think about using biology to connect devices and I'm not even going to try to. I can't even.
I hope to follow up then with a few things. Honestly, I've been trying to note take as quickly as I could with.
Ted's put me on the spot. He embarrassed me now because it's this one thing I just haven't looked at for a while. And actually the solicitation was late last year, and those awards were last year, and I just don't remember all of them. But it's a great question, and if you want to know more about it, I would contact Paul Lane, because right now they just had a PI meeting, and that solicitation is going to come out again. So if it's something you're interested in.
I'm very interested in it.
And it's like one of those things I'm not leading, so I know it, you know, I don't know it as well as I know other things. So I apologize for that. Ah, he caught me, damn it.
Well, how are you going to have all of those programs in your head?
I try.
Well, I have a few questions. I guess, you know, two projects I think that really stood out to me was one, the ADAPT program. If I say that correctly, right, by John Schluter. And so I'd be super interested in just learning a little bit more about, okay, what kinds of AI tools and ML tools, you know, is that program envisioning of?
Okay, it's not a program. The 4 bullet points that I showed you were areas that people would need to be competent in order to use AI. And so if there are researchers that want to send their student to bring that knowledge back and learn about it, or if a PI wants to add a collaborator through a supplement so that they can add AI or ML approaches to maybe some data that they're generating from their project, that's what that's meant to be. The AI institutes are much bigger than that, and those are really trying to create the tools and the sharing of tools for the community in order for, say, chemistry or physics to have the correct tools as we advance further and further these algorithms for handling all the different types of data that's out there, and trying to do the things that Ted was saying is just using that to really inform us, you know, in doing our experiments and learning new things and so on and so forth. So this is all new to me too. So
yeah, well, it's interesting because at almost every one of our technical competition, sooner or later someone asks the question of like, okay, what kind of enabling technologies do we have? You know, is there any way? Because so many times I think, you know, often, you know, folks are in their silos, and it's really hard to see what other AI ML tools could potentially be out there to advance their research. So I'm super excited to see this this research institute pop up, and be super keen to learn more, I guess.
Well, I challenge you too. I mean, if you see people that are already funded to do these things, and you want to bring a group of people that don't have access, we could do a square table on that too, and that way you can learn new things. I mean, this what makes my job fun. I mean, that's why we're here. We want to promote science and the best out of science. So, you know, having these little small activities and small seed fundings helps really have big impact. So.
Okay, totally. Well, this is duly noted. And then I was also super interesting to hear a little bit more about the designing materials, revolutionize and engineer our future. And you know, what's that about? And can you share a little bit more on specifically how? Yeah.
Absolutely. So that program was created because typically, you know, computational folks and experimental folks have a tendency to kind of do their own thing. And then when they need some support for models, they'll go talk to their theoretical or computational people, but they don't necessarily typically work together and iterate their knowledge. And part of the reason for that program was to initiate that vision of MGI to get at all levels, whether it's fundamental science, but also, in the development stages, that you got to continually have that iteration of knowledge. But also, you also have to integrate the data that comes from all of those experiments, whether they're computational or physical experiments. And so DMRAF was created to get teams to think about working together that way. So I would say the first couple projects we had some great teams. They talked about data, but they didn't know what to do with it or why they would have to share it with anybody. And they worked in parallel, just like they typically do in any type of team project. They worked in parallel and consulted each other when they thought they needed it. But the DMRAF project, you have to demonstrate how what you're doing here in this, say in your experiments, are going to help the person that's doing computations or models or simulations, going to help them advance what they need to do to advance their field. And so it's really trying to enhance iteration, not just integration, but iteration of knowledge between those types. And so we did that the first couple of years. And you started to see people working together, but we weren't seeing any data-driven materials research or even any inkling of wanting to share data with anybody. So we modified the solicitation again, and we tried to get the community to start thinking about, you have to have the data-driven part. You have to have a plan for that. And that got incorporated in there. So the data and the sharing of the data, like I showed you in the big materials innovation platforms, but in a team, you had to start doing that sort of thing. And then, of course, with machine learning and AI now accelerating much faster than when DMRAF started, we're seeing much more of that being included in the project. So it's basically been a team program to encourage this idea about teamwork and using MGI approach to advance the discovery, the development, and then eventually deployment, which we actually had success doing, of materials faster. And it was also meant to get the fundamental science, whether you're a condensed matter physicist or a chemist or a real material science and engineer, to talk across all those different disciplines. And so we bring all those teams together to talk about how hard or easy it is to share data and all those different things. So that's part of why the program was created. The second part of it is, and like I talked about before, it's not just about the data and being able to do things faster. It's in a team, but how do you move that out of the team and translate it down the materials development continuum? So one of the things we've been doing is bringing our teams together, and we've had these big PI meetings where we bring in other agencies. So we bring in NIST, we bring in Air Force Research Lab, we bring in DOE, and they go around and talk to all the teams. And NSF, DMR has provided supplements to connect our DMRAF teams to other agencies. So we have connections with NASA and NIST and Department of Energy and Air Force. So the teams are kind of seeing how what they're doing in their iterated fashion can go to the next step down that materials development continuum. So trying to, like you said, link what we're doing in MGI between the agencies that have different missions. So I don't know if that helped you. That DMRAF is not just about doing great science. It has a mission, and the mission is MGI. So it's a little different. So people come in and it's heartbreaking. They'll come in with this great science project, but it doesn't really meet the criteria of an MGI envisioned DMRAF project, and we have to decline them. And it's heartbreaking, but it has a mission. So that's why that program is different. So I hope that was helpful to everybody. Every time we have a solicitation, we look back and see how the community responded, what they've been doing in their projects, and then modify and talk to our collaborators in other agencies, and then modify the solicitation accordingly to slowly bring the community a little bit farther down that materials development continuum. So
yeah, I must imagine the data standardization, or even just using data across different silos must be really hard, because even at our technical meetings, we struggle just even among research groups to try to come into a way where that research data generated by one group is useful for the other. So I can only imagine how that must be that must be quite the challenge. I guess in the only 3 minutes that we have left, I would love to know a little bit more about, like, if you can give one, like, what's the kind of like future outlook of the NSF? I mean, for as much as you can share, or and what are ways in which this group could perhaps be useful? So this is usually kind of like a catch-all question to if I say to people, okay, there's the action items in the very last minutes, then this would be a really good opportunity to share anything of like, okay, go on this website, or do this and this, just as a catch-all in case you have anything that you really want people not to miss during the whole presentation.
So I think the main things is those we do studies, and we put reports out for a reason, because we get that input from the community. Those studies are also things that we do because the government, the taxpayers are really our customers, and they're the ones who pay for all the great research that you do. And so, the government does let us know things that are priorities. So those studies are really important. And so aligning your research so that it has an impact on what society needs is really important. So it's not just a secondary thing to get funding, but it is really important, and we need you to think about that. I think the other key is you need to be vocal. I mean, I'm more than happy to hear from the community. Tell me what you think. And I think a lot of the program directors and other division directors want to hear more from the community. If you want to do more activities that you think something's missing, that there's no funding opportunity for it, let's have a square table. They could just do a small, even a get together like this or something to initiate things. So I think, NSF is your partner. I think that's the message I want to see. We don't work for you. We work for the public good, and we can't do our job without all of you, because we don't have all the expertise to evaluate all the great projects that come in. And so we depend on you. So I'd like you to go away thinking that you're a partner with NSF. So that means that we also, give us more of your information, even unsolicited. You can come in and talk to us and tell us what you think. So I hope that's helpful.
Very much so. Yes. Thank you so much for joining. I would be, again, super grateful if you could share the slides, and then I'll try to link to the most important bits that you shared.
Okay.
And thank you so much for joining. I think that you probably get a lot of emails off in the
Okay, well, I want to thank everybody for taking the time, and you, Allison, for inviting me, and all of you for taking the time to, listen to me ramble on. Feel free to, contact me if you have questions or anytime.